In this video, we are going to discuss about the naming of organic compounds. Naming of organic compounds. Now, name of any compound can be of two types. It can be a common name according to the common system, or it can be an IUPAC name according to the IUPAC system. What is the full form of IUPAC? It is International Union of Pure and Applied Chemists. Now, if we talk about the common system, in the common system, the name is based on either one of its property, or it may be based on its appearance, some physical property, or it may be after the name of the discoverer or a place, etc. etc. So, this common name may vary from place to place, it may change. That is why, just to have a universal name for a compound, we follow the IUPAC system. IUPAC naming is done on the basis of certain rules. There are certain rules and regulations following that we do the IUPAC naming. We are starting with the IUPAC names. Now, what about the IUPAC name? How do we do it? IUPAC system, according to that, in any IUPAC name of an organic compound, there can be three parts. What are these three parts? One is the middle part, which is called as word root. Before word root, we have prefix, and after word root, we have suffix. Now, coming to word root, how do we select the word root, or what is a word root? Word root depends on the number of carbon atoms. Depends on the number of carbon atoms. How many carbon atoms are there? According to that, word root is selected. Now, what about the suffix? Suffix can be of two types. It may be a primary suffix, it may be a secondary suffix. Now, as the name is indicating, suffix comes after what? After word root. Now, primary suffix is always depending upon the type of hydrocarbon. What does it mean, type of hydrocarbon? Whether it's a carbon carbon single bond. If carbon carbon single bond, it means it's alkane. That's why the primary suffix for the single bonded carbon carbon compounds should be ane. So ane should be the suffix. But if there is any carbon carbon double bond, any double bond is there between carbon and carbon, then it is going to be alkene, and that's why the suffix will be changed, it should be ene. Now, what about if there is a carbon carbon triple bond present? If it is triple bond present, then it's going to be alkyne, and accordingly the suffix will be ine. Now, coming to secondary suffix. What about secondary suffix? Secondary suffix depends on the type of functional group. If there is any functional group, accordingly the secondary suffix will be chosen. Now, moving to the prefix. What about prefix? Prefix, as the name is indicating, should be before word root. Anything which comes before word root is prefix. Now, prefix again can be of two types. It can be primary prefix, it can be secondary prefix. Now, what about the primary prefix? Primary prefix that depends upon whether the compound is cyclic or not. If the compound is cyclic, we use a primary prefix that is cyclo. But if there is no cyclic compound, it's a straight chain, open chain compound, then we don't use the primary prefix. There may be secondary prefix. Now, what about the secondary prefix? Prefix depends upon the substituent. If there is any substituent present, secondary prefix may be there. So that is how we can have the three parts in the name of an organic compound. Now, coming to the word root. Word root depends upon, as I discussed about, that word root is depending upon the number of carbon atoms present in the parent chain. Number of carbon atoms. Say for example, if one carbon is there, the word root should be meth. If there are two carbons, the word root should be eth. If there are three carbon, it should be prop. If four, it should be but. If 5, it should be pent. If 6, it should be hex. If 7, should be hept. If 8, should be oct. If 9, should be non. If 10, should be dec. If 11, should be undec. If it is 12, then going to be dodec. So in this way, we can have various word root according to the number of carbon atoms present in the parent chain. Now moving to the next, the primary suffix. Primary suffix is depending upon the number of carbon atoms, depending upon the type of bonding present between the carbon atoms. So accordingly, we choose it, whether it will be ane, in, or ein. So that is how we can have the primary suffix, and we can have the secondary suffix also if there is any functional group present. So now let's start with the naming without any functional group. We are starting with the naming of aliphatic hydrocarbons. Naming of aliphatic hydrocarbons, and in the aliphatic hydrocarbons also we are starting with the naming of alkanes. We are starting with the naming of alkanes. Alkanes, the general formula is CnH2n plus 2. There n may be 1, 2, 3, etc. Now say for example, if n is 1, the formula of the compound is going to be CH4 if n is equal to 1. If n is equal to 2, the formula of the compound is going to be C2H6. So that is how we can have the entire homologous series of alkanes. Now we are moving to the rules for naming. Now what about the rules for naming? The first rule for the naming of any compound is select the parent chain. Select the parent chain. Now, what are the rules for selecting the parent chain? What conditions should we follow? One is that the chain should be longest. Second condition is that should be continuous. So, the chain which is going to be the longest means maximum number of carbon atoms is the should be the parent chain. And similarly, if there is continuous carbon atoms present, then that will be the parent chain. Now let's take the example. Let's be more clear about it. Say for example, we have 1, 2, 3, 4. This is one carbon chain. So here there are 4 carbon atoms and the chain is in continuation. All the carbon atoms are in continuation 1, 2, 3, 4 without any discontinuity. So this is going to be the parent chain. That's how we select it. Now what about the carbon atoms? Because what about the hydrogen atoms? The carbon cannot exist alone, so there has to be hydrogens also. Now how many hydrogens should be present? That C, you can see here that carbon 4 is bonded with one carbon, so it already has one bond. Remaining 3, because we know carbon is tetravalent, so remaining 3 will be satisfied with the 3 hydrogens. Here this carbon 3 is bonded with 2 already, so only 2 are to be there, so they will be like this. Similarly, again 2 should be there, and here 3 should be there. So that is how we can have various carbon atoms bonded with the hydrogens, right? So this is what select the parent chain. This is the longest chain, only one possibility is there. Now what if we have this kind of chain? Here you can see the branching is there. Branching is there. Now here one carbon chain which is possible is this. This is the longest chain which is continuous also. This is the longest chain which is continuous, containing 5 carbon. Right? Now the other possibility is which can be selected as the parent chain is like we can have 1, 2, 3, 4. You can see that these 4 atoms are in continuation. So that is how this can be another parent chain, while these 2 will be the separate atoms. So this is another parent chain possible. Continuous chain, 1 2 3 4. We cannot select the chain in this way, 1 1 2 3 4 5 6. This is wrong, because this is going to be the discontinuous chain. So either we may have this chain, or we may have this as a parent chain, or we may have this as a parent chain. The chain can be like this also, like you may see here. Say for example, if the carbon atoms are like this, 1 2 3 4, like this, then this will become the substituent. This is not the part of parent chain, this is the parent chain. So you can see that there are three continuous chains possible, but which contains maximum number of carbon atoms? The chain with the maximum number of carbon atom is this. So that is why this has to be the parent chain, because this is longest and continuous chain. So this is the first rule, select the parent chain. What is the parent chain? What are the conditions? That it has to be longest and continuous. Now moving to the next rule. Identify the substituent. Identify the substituent. Now what about this substituent? What is the substituent? Substituent is what? It's the side chain. Side chain means the carbon atoms which are not part of the parent chain. Like if I talk about this parent chain, here this is substituent. If I talk about this parent chain, this is the substituent. If I talk about this parent chain, this is the substituent. So that is how you can see the substituents are. What are substituents? Which are bonded in the parent chain by in place of one of the hydrogen, right? This entire one is one substituent. Why is it one substituent? Because it is obtained by substituting one hydrogen only, because substitution in the parent chain happened only at one place, only at one place. So that is why this is what? This is the example of the one substituent, like this. You can see that this is the parent chain and substitution happen only at this place. So that is why one substituent containing two carbons, right? So that is how we should identify the substituents. Now moving to the next. What is the next rule? Select the word root. What is word root? The word root is selected according to the number of carbon atoms present in the parent chain. Now here, because this chain is the longest chain, this chain is the longest chain, that is why this will be selected as parent. And how many carbons are there? There are 5 carbons. So 5 carbons, that is why the word root is going to be pent. Now what else we require? We require the primary suffix also. All the carbon bonds are single bonded, that is why it is an example of alkane, and that's why the primary suffix should be pentane. So that is how we selected the word root, added the suffix to it, added the suffix. Now if there is a substituent present, then we have to use the prefix also. What is the prefix here? Depending upon the number of carbon atoms. Like here, the substituent contain only one carbon. So one carbon, what should be the word root for one carbon? That is meth. And always for the substituent, the suffix is used as "il", right? So what is the next thing? Next is identify the substituent, name the substituent. Name the substituent. How do we name it? Select the word root for the substituent according to the number of carbon atom. Number of carbon atoms, right? So name of the substituent. So say for example here in this case we have only one carbon, so that is why the word root is meth. And whenever there is a substituent coming, we use a suffix that is "il." So what is the name of this substituent going to be? It is methyl. So the fifth step is done, that is name the substituent. Now the next step is number the or give position to the substituent. Give position to the substituent. How do we give the position to the substituent? By numbering the carbon atoms in the parent chain. How do we number the carbon atoms in the parent chain? We number in such a way so that the substituent gets the least number. So we can number it from here 1, 2, 3, 4, 5. So the substituent, that is methyl, is at number 3. So what is the name of this compound going to be? If I write the compound again, what was the compound? It was CH3, CH2, CH, CH3, CH2, CH3. This was the compound. Here we selected this as the parent chain, and we selected this as the substituent. This is the substituent present. Now we selected the word root according to the number of carbon atoms present. We selected the word root according to the number of carbon atoms present in the substituent. We give its position 1, 2, 3. Whatever the side we number it from, whether it is left to right or right to left, the substituent is at number 3 only. So that is why the name of the compound is going to be 3-methyl pentane. 3-methyl pentane. Always remember, there is a hyphen between a number, hyphen between a number and an alphabet, between a number and alphabet. You can see here it is like this, that there is a hyphen and there will always be a comma between the two numbers. So that is how we can name a compound. Thank you.